In question 3, you've got a graph more of the format y is equal to a, b, the x plus k. As that's positive, we're expecting a graph that hooks up. We're going to be bringing that down, however, to y is equal to -2. Now, it's probably instructional to have a look at how this would look on your calculator before progressing further. Now, I've opened up my calculator and fiddled the axes a little bit. I've got y is equal to 4 to the power of x plus 2. So you can see that growth factor. You can see the asymptote at -2. What I might do, might actually just use the zoom box and just zoom in on that a little bit, and we'll see how that goes. So you can actually see the asymptote at -2. You can probably suspect a y-intercept of 1, and we'll have an x-intercept between 0 and 1. Very, very handy early on, particularly if you can check these using your calculator. So the x-intercept, because it crosses the x-axis, occurs, I better write that down, -2. That occurs when y is equal to 0. So therefore 0, 4 to the power of x, is equal to 2. And that works out being x is equal to log 2 to the base 4, which you can do on your calculator of 0.5. So I've got the point, 0.50, and that's pretty much what my graph says. If you want, analyze, choose solve, root, and you can see the point 0.50. The y-intercept when x is 0, so therefore 0, -1. It then remains for me to sketch the graph. You'll notice I'm using quite a bit of paper as I do this. It's the way these problems tend to run. So my horizontal asymptote at x is equal to -2. The y-intercept, the x-intercept 0.50, and haul up on that basis. Take some time to have a look at that, and you can see it looks pretty much like the graph I generated on my calculator. Before commencing 3B, it would be instructional to have a look at this on your calculator. Now you can see here the graph of 3 to the power of x there, cut the axis at 1, I'll have a point at 1, 3, and you can see there that the 3 to the negative x reflects it in the y-axis and also displaces it a bit. So what we'll see there is a reflection and a movement back to the left there. Now in order to plot this graph, we'll have a horizontal asymptote at y is equal to 0, so I better put that there, and I'll plug through and find the other values. So I've got a y-intercept of 0, 1/9, another point. Now you can choose a range of things. I've actually read ahead a little bit, obviously. I'm going to make that -3. So when x is equal to -3, as soon as something doesn't cut the x-axis, just use a bit of imagination and maybe a bit of gumption in order to work out a reasonable point. So I've therefore got -3,3. And that would correspond with what my graph's looking like there. With that information, I can then sketch up my graph. Now, it's kind of hard to show a 9th. My graph obviously almost touching the x-axis, but never ever. So what I can say for the domain, element real numbers, And the range, well, that goes from 0 through to positive infinity. Take some time to look at that and work it through.